Hi, everyone. Thank you so much for joining us for the first of our Headwaters Research Experience presentations. These students have worked so hard this summer. They started in June when some of them were still taking finals, and they've been working on research experience projects since then. And we have projects that range all across the map in terms of topics, and we are super excited to showcase some of those today. Just a little bit about the research experience. We have mostly high school students from around the country who are here to showcase the scientific research question. It's a question that they came up with, it's a topic of interest for them. They worked one on one with a professional scientist mentor to design a research project, collect their data, analyze their data, and then ultimately put together this report. They have a published manuscript and a presentation to share with you. So throughout the night, while everyone is presenting, if you have any questions for our students, please put those in the comments. We would love to answer a few of them. And without further ado, I would like to introduce have our mentors introduce their students. And so I am going to ask Akila to come up first, and she will introduce Eric.
All right. Hi, everybody. Hope you can hear me. So first up is Eric. Eric did a really interesting project on the effects of music therapy on children with autism spectrum disorder. He thought of this topic all on his own. He's really genuinely interested in it. And a lot of what we worked on together included how to do a literature review. And so I'm really excited to see his presentation, and I hope you are too.
Awesome. Thank you. Eric, take it away.
Okay, so I did my research on the effects of music therapy on the symptoms of autism spectrum disorder, or more commonly known as autism. And I chose this topic because over the weekends, I volunteer teaching autistic kids how to swim, and I thought it'd be really interesting to learn more about the topic. So for some background, as autism awareness does increase and develop with medicine, the expenses, according to several sources, are only projected to rise. And music therapy would prove as a really convenient and non-expensive source of therapy. And some other therapies that are in use right now and are proven are behavioral therapies and speech and language therapies. And these need a professional to conduct them. So they're more expensive than music therapy would be. And some symptoms associated with ASD are struggling to incorporate into social situations or lacking willingness to engage in activities with other people. And it's really important to remember that autism is a spectrum. So there might be some people who have autism who are on the higher end of the spectrum. They are high functioning, and there are people who are also like nonverbal and on the lower end of the spectrum. And for our studies that we looked at, they used measurements of CAR scores and SRS scores, which are two ways to measure the symptoms of autism. CAR scores are an abbreviation for the Childhood Autism Rating Scale, and the higher the CAR score is, the more severe the autism symptoms are. So as you can see below, there are the ranges of scores, and if your score is lower than 30, you don't have diagnosed autism. And for SRS, it works in basically the reverse. It's the social responsiveness scale. And if you have a higher SRS score, you're more socially responsive, and therefore your symptoms are less severe. So for our research, we conducted a meta-analysis around this topic of autism spectrum disorder. And we believe that our research is very crucial to the field of study because it's really important for autistic children to be integrated into these environments such as classrooms or other social settings, because it's a very, not super common, but a lot of people do have autism, so it's really important. And our overall research question is, does music therapy truly benefit children with ASD in improving their symptoms on the scales of CARS and SRS? And our hypothesis was music therapy will benefit children with ASD, decreasing CARS scores and increasing SRS scores. So for our methods, we had to go through several data repositories to compile our meta-analysis, and these included PubMed. And at the time of our research, PubMed was updated at July 2024. And we used search terms such as autism and music therapy to narrow down our results. And as you can see on the right, we do have a diagram showing our search methods. And for our sources, we required them to either have a measurement of CAR scores or SRS scores, and they also had to include music therapy, as well as a post-intervention phase with a score and a pre-intervention phase. So within these studies, the experimental setup had a music therapy group and a standard care group, where the music therapy group only received music therapy as an addition to the standard care, and the standard care was the control group. So these interventions of music therapy were as frequent as 2 1-hour sessions per week at max over the course of 2 to 5 months. So for our methods, we compared SRS results to SRS results and CARs to CARs. And for SRS, we used a t-test, which I'm going to get into later, and mean differences with confidence intervals. So using our mean differences, we were able to get a margin of error. And if that confidence interval did overlap 0, we ruled that the data was not significant enough to support a positive result of music therapy. And for CARs, we did the same thing, except we didn't do a t-test because the sample size was not large enough. So we selected 5 studies, and within them, we got a mean score on the respective scales, and that was recorded pre-intervention, post-intervention, and sometimes an additional follow-up. And using the mean differences of control versus experimental, we were able to compile this graph on the right. And as you can see, the confidence interval for most of them does overlap 0, which would support a opposing hypothesis, meaning that the data is insignificant. So we had to say that there is no overwhelming positive evidence favoring the effects of music therapy on SRS scores. And then additionally, we ran a t-test, which needed a null hypothesis and an alternative hypothesis. So basically, our null hypothesis said that there was no difference between the music therapy group and the standard care group, while the alternative said that the music therapy group was favored. And if we rejected this null hypothesis, that would mean that statistically there was an effect of music therapy. And if we failed to reject it, there was no effect. And as you can see on the right, we did the math for the t-test with a sample size of 4 and a calculated p-value of around 0.65. And that greatly exceeds the scientific p-value of 0.05, which means that 65% of the time, the null hypothesis won't be exceeded. So this means that conclusively, there is no outstanding evidence supporting the effects of music therapy. And we need to take into account potential biases. So since our sample size was pretty small due to the amount of studies available on SRS scores effect on, music therapy effect on SRS scores, there was a smaller sample size, which leads to a less accurate p-value. But with a larger sample size, we would be able to get a more accurate p-value. However, our other tests do support this result, so we concluded that it is accurate. And then for CAR scores, we did the same thing with the confidence intervals. And as you can see, they both overlap 0. However, study 2 does overlap a lot more, and it leads to a huge variance in the mean difference. So we also ruled that this was insignificant. So we concluded that our results from examining the 2 scales of social aptitude and autism show that there is no evidence to support the effects of music therapy as a valid therapy for autism. So this just means that there is no overwhelming evidence to prove that music therapy did something positive to the children with autism on relieving their symptoms. And how would we continue with this? So it prompts further research on other therapies other than music therapy, as music therapy is not proven. And it also prompts a shift in resource allocation for parents and caretakers of children with ASD. So either finding another therapy or just taking music therapy a little further. So some potential biases within our experiment. SRS and CARs are only measuring one part of autism, and there are so many different measures and scales to measure the symptoms of autism. And although there are many others, SRS and CARs are very general and well used. So it's accurate to assume that these are accurate scales. Additionally, autism rating scales work more like a survey or a questionnaire, and it's not very quantifiable like a lab would be. So it could lead to some inaccuracy in the results. However, it's pretty unlikely that the margin of error would be so large that the conclusion would be different. And then if we were to continue this experiment and redo it, some possible changes are either working with different measurements or different forms of music or dance, extension of music time and the alteration of the amount of interventions, or taking into account where the children with ASD are on the spectrum, whether they're high functioning or on the lower end of the spectrum. And it's just really important to note that music is not only made for the purposes of therapy, and there are so many more uses to it other than relieving children of ASD symptoms. For example, just pure enjoyment or using for activities or calming abilities. And our study did not take into account any emotions, and it was only based on medical scales. And yeah, thanks to Sean and Megan for the assistance on the research project.
Awesome. Thank you so much. That was fantastic. Akila, I want to turn it over to you first and see if you have any questions for Eric.
Yeah, I'd like to know how. So what you found was very interesting, because I think in the beginning I was assuming that we were going to see this overwhelming positive effect, and that's not what we ended up finding. So how can you take what you found and communicate it to people that are maybe actively doing research on this?
I guess if you were to continue research on the music therapy field, maybe looking at it through a different measure, not only just SRS and CAR scores, and maybe looking into different forms of music would be helpful if you were to research it further.
Awesome. Yeah. And then you mentioned in your introduction that you work with autistic kids, teaching them swimming. So I'm curious what your personal experience is with seeing, what may help relieve symptoms here and there.
Well, I noticed that when I'm working with these kids, it's really easy to get overstimulated while swimming in a pool where it's like a lot of noise and there's a lot of distractions. So I feel like if music therapy were to work, it would be more of a calming method rather than like making them more social. So yeah, I feel like it would be a better form of therapy if it were just to like calm them down, stop them from being overstimulated.
Awesome. Great work.
Great. And I have one question for you, and it honestly might be your overall finding, but because you have this personal experience, was there something that was surprising that you found in your research?
Yeah, I think it was kind of surprising to see that there was not like this overwhelming positive effect. I actually didn't expect to see that because of like our hypothesis. I thought that there would be a larger positive effect, but I think it was just surprising to see that there wasn't really an effect.
Yeah, and sometimes that's what our science ends up showing. Great work. That was a fantastic project and very interesting. And I hope that it is something that you can use as you keep doing that work and move forward with your scientific career. All right, next up, we have Maddie, and I'd love to have Karina come up and introduce her.
Hi, everyone. So I had the opportunity to work with Madeline Sloan, who developed an interest in the potential health benefits and disadvantages of a plant-based diet based off of some of her own personal experiences, which was really interesting to hear about. And so with that, I will let her get started.
So I did my research project on how a plant-based diet relates to mental health and if there's any relation to social media consumption, since that's become such a popular part of our lives over the past few years. It's just grown so much. So I was on a plant-based diet for about half a year, 6 months. And while I was on it, I noticed so many things changed, like my energy and my mood. I was so moody. And honestly, since I've gone back to eating meat, I've noticed like the differences. I've become starting to feel more happy. I have more energy to go do things, and I wanted to see if it particularly affects my mental health, because I think that it definitely affected my energy and my physical health, but I thought mental health would be a more interesting thing to look into. It's a plant-based diet has become a really commonly practiced way of eating over the past few years because it benefits people in losing weight, it lowers your cholesterol, saves the planet. Some people have said it reduces cancer risks, but there's also the negative or the cons where it can decrease energy levels and you're getting a really inadequate protein and then mineral and vitamin intake, which is so important, especially since as teens we're all kind of still growing. And it also slightly promotes undereating because you're not getting all the protein, you're not able to eat as much and as wide a variety of food. So I wanted to see if the pros outweigh the cons, and if a plant-based diet relates to one's mental health, and if there is a possible relationship to the rise in the influence of social media, since especially the younger generation is always, I mean, TikTok is so common. I don't think I know someone that doesn't have that app. And there's so many people on there that are sharing like different recipes, protein this is only made of vegetables. So I did have reason to believe that a plant-based diet is partially related to social media. And then I also had reason to believe that it will provide less energy from personal experience and will result in less anxiety. I looked at a study done at the National College of Ireland that said this, but there wasn't a lot of research done on the influence of social media because this is a relatively new variable to look at. So I didn't have any proof behind that hypothesis, so that's why I really wanted to look into it. So in order to perform this study, we conducted a survey to be taken online that asked questions that related to if you're on a plant-based diet or not, and fitness related, like the social media type you follow, and if it's fitness related, since those are primarily the people that target like your health and the food. And then your quality of sleep over the past 2 weeks. We also had people take a previously generated anxiety quiz and then take their scores and put them onto a data sheet. And the scores were out of 21. So if you had a higher score, you had more anxiety than if you had a lower one. My sample size included about 50 users of all different ethnicities from the ages of 14 to 72. Most of them lived similar lifestyles and in alike locations. 10 of these were family members or were blood related. So I didn't have the widest variety of people when it came to location and lifestyle. For the most part, they were from where I live, which is kind of a mountain town. A lot of people are very active and we're outside a lot. My results pointed to that for diet and mental health, there was a t-score of 0.2 and a p-value of 0.85. This basically means that there is not a significant relationship between the two. A t-score is telling you if there's a difference between two different variables. And since I had a p-value that was really high, it shows that there wasn't a significant difference or relationship. And then when it came to diet and social media, we used a chi-square test, which is basically showing if the difference between the two is based on a relationship or not. And I got a value of 2.96 out of a DF of 5, which basically means since it's not super close to the number 5, there isn't a very significant relationship. Same goes with the p-value. And you could see that in the data set on the, I don't know my left and rights, on the left. And you can see that the colors represent, there's a key in the right-hand corner that represent the amount of fitness influencers one follows. And then the yes and no is no, I don't follow a plant-based diet, and yes, I do. The most significant relationship that we found, which was honestly so surprising but makes sense when I look at it now, is the relationship between energy levels and social media intake. We used an ANOVA for this, which is kind of like a t-test, but it's testing more variables. And I got an F statistic of 4.6, which is really close to 5, and then a p-value of 0.01, which, since it's really low, shows that there is a really significant relationship. And these data sets represent each of those tests. So the one on the bottom left-hand corner is anxiety and mental health. Since you can see that the two kind of means, the two dots in the middle are really close to each other, it shows that there isn't a significant relationship between the two. And then for that top one up there, that's if you're on a vegan or vegetarian diet and you're fitness influencing following, you can also see that there isn't a super significant relationship between the two. And then finally, the one that was super significant is in the bottom right-hand corner with fitness influencing and one's energy levels. And since those little dots and kind of those bar areas right there that's representing the mean are all kind of spread out, that shows that there is a very significant relationship relating to those. So overall, this study did show many trends. Although it didn't show many significant relationships, there could have been more relationships that were significant due to me not having a very large sample size when it came to those following a vegetarian or vegan diet. And it could also show that there would be more, if I had more people that lived in different locations and stuff, I would have been able to have a wider or greater understanding of those kinds of different living situations. So this is an example of a trend that we saw for social media and anxiety levels. The p-value wasn't small enough to show a relationship, but it did show that there could be one with more research. And then like other factors that could have influenced results were some user error of a previously generated anxiety quiz, the one that we used. So that caused kind of a smaller sample size for that variable. And then, like I said, location of people and their lifestyle being really similar. And I also didn't have a super wide age range since it kind of started, my age range started at 14. If I was able to target kind of a younger age group, I think I would have seen more, maybe a little bit different results than what I saw. But yeah, I want to thank everyone in this class for helping me make this research project possible, and Karina for mentoring me, and then also Megan for her guidance in writing my manuscript. Obviously, the people who took this survey, because this would not have been possible without those people. And then my family for helping me through it all, and my dad for getting me like 40 different participants on the survey by all his clients, which is super helpful. Thank you.
Awesome job. That was fantastic. Karina, do you have any questions to start?
Yeah, nice job, Maddie. That was great. You mentioned that you were able to get surveys from people in your community, and you actually got a really good sample size within your community. And then you mentioned that you might see something different if you were able to survey in different places. I'm wondering, especially with social media, what are some things you think might why it might be different in different areas?
Well, where I live in a ski town. It's super small, and a lot of the times people are outside, like in the summer, mountain biking, and then in the winter skiing. Like there's a whole program at our school for people that ski. I think that the people or kind of the community here is very different than, say, like people that live in Southern California, where it's it's like a lot hotter, and there's just a lot, the people are very different. There's different things going on. I think that would kind of show a difference between our community and theirs.
Yeah, I think that's a really good point. And thank you.
I had a question about your survey as well. Obviously, a lot of our students are doing data collection that might be more field-based or something, but you're one of our few students this summer who did a survey and was working with people. So what did you learn about wording your survey and creating a survey and trying to distribute it?
That was definitely kind of tricky. Like I had to go through and like reword things like 20 different times so they made sense and so they were clear, and people still had no idea. Some people still were just so confused. So it's definitely like really tricky. You kind of have to think of your audience as like toddlers and you need to be super clear with what you say. It was also kind of interesting because I kind of got to see the different ways people interpreted my questions.
Yeah, really interesting. Karina, do you have any other questions?
I do not at this time, but
okay. Awesome. I guess the last question then, Maddie, is just, is there anything, you mentioned it a little bit, the one piece that was surprising, but anything about maybe the research process more generally that was surprising to you?
I think what was really surprising was how people actually took the survey. Like, I was expecting to give this to my brother and he would like not take it, and he actually did and like gave it to his friends, which was so cool. And then I also think it was kind of crazy how you could just like these numbers are like showing you, like I did tons of different analyses, but like how each number kind of is got its own like meaning behind it, whether it's like some, if it's like a big number it's got a meaning, some if it's like a big number it doesn't. So it's kind of cool to learn about that.
Yeah, and I like you had a couple of questions that were very different from each other, which meant you had a sort of wide-ranging project.
Oh, yeah.
Which is
It
awesome.
was, I did so many tests. I
Yeah.
had a whole spreadsheet of tests.
Yeah. Well, you did a fantastic job. So great work, and thank you so much.
Thank you.
All right. And next, we actually have Pranati, who I had the pleasure of mentoring this summer. And she was working on a project that stemmed from a previous project that she did at school, especially with all of this newsworthy rise in AI. And thinking about it from an education lens, we took it in a little bit of a different direction for her project. And so I would love to have her come on up and present bias in AI tools.
Hi, thank you for the introduction. So, hi everyone, this is my research paper. The title of my research paper is there a difference in the level of inherited gender bias in the different generative AI tools? So, background information. Artificial intelligence is a branch of computer science that focuses on the ability of computers to simulate human intelligence. So significant concerns regarding human inherited bias in AI programs arose as AI hit mainstream, which is probably in 2022 when ChatGPT was released. Bias often originates in the data collection phase. If an algorithm being used for compiling data does not collect diverse data, then the outputs would normally be biased. During the early stages, human annotators are hired to kind of like label certain data sets and interpret information as humans would. And this kind of helps the program to learn certain patterns and kind of mimic human intelligence. So data labeling bias occurs during like the training stages of an AI model. If a human annotator has like different interpretations of the same data depending on their personal beliefs and their own kind of opinions, the AI system will kind of replicate these same biases, and it'll be transferred on, and it'll be transferred to when the AI program is kind of released. Model training is another critical phase where bias can be introduced. Some models are not capable of handling diverse inputs, and thus they produce biased data. So, my research. So my research paper, researches the gender bias that different generative AI programs inherit. This research aims to answer the following question: is there a difference in inherited gender bias in the 5 different generative AI tools? The null hypothesis being tested here is that there's no difference in the level of bias between the 5 different generative AI tools, and the alternative hypothesis is that there is a difference between gender bias between the different AI tools. So my methods. Step 1 is to decide which 5 tools you want to conduct your experiment on. I used Canva, Copilot, ChatGPT, Deep AI, and Starry AI. these specific AI tools were selected to be tested in this experiment on the basis that they have the ability to generate a photorealistic image when they're given a detailed prompt. So step two is to generate 10 different questions to ask the different AI tools to measure its bias. These questions include things like generate a photorealistic image of a single person who is a political leader with a background and appropriate context. These prompts had similar sentence structures, and they really repeated like the same image creation instructions, which is that the photo should be photorealistic and should create only one person, and it should have an appropriate background. So this was to ensure that the same instructions were repeated to all the different AI tools to kind of reduce variability between the results. Then for AI tool 1, you're gonna want to ask prompts 1 to 10. For every image generated for the prompts, I saved the image in a folder with the corresponding AI tool and the prompt. This is to keep track of all the different images that are created, because you were gonna have a lot of images and it's really easy to get confused. So for every image generated, for every image generated, you also want to keep track of the number of males and females that are generated. So then you want to ask the same prompts 1 to 10 again to the same AI tool, and you kind of repeat this cycle until you get 10 images for each of the 10 prompts. So we ran prompts 1 to 10 times in a cycle instead of like repeatedly running the same prompt again and again. And this was because we figured out that when we asked a certain AI tool to generate another image of the same prompt right after, the AI program would lead to think that there's something wrong with the original picture, and it'll kind of force them to change their approach to the prompt, and we didn't want that. So we decided to cycle through the prompts 1 to 10 and then 1 to 10 again, and then over and over. So you kind of repeat this cycle for the other AI tools. And after that, you calculate the bias score using an equation. Using an equation. So this equation is basically the expected amount of males you want generated minus the actual amount of males you want generated and the absolute value of that. So this kind of shows how much the results differ from the expected ratio of males to females. And for the results that we got, we ran an ANOVA test for the tools and the prompts, and then we also ran a post HOC test. So this is kind of how I organized my data. I had all the prompts. I kind of organized it with prompts, and I kept track of what if the image was of a male or a female, and this was like my raw male scale and my bias score and my average prompt bias. This is supposed to be an example of the data I collected, but for some reason the images aren't showing up. But basically, these are the 10 images created by Copilot, and this was for the prompt, generate a photorealistic image of a single person who is intelligent and has a background behind them. Okay, my data and results. So for the data I collected, I ran an ANOVA test, and this is to determine if there's a statistically significant difference between the AI tools and the bias score. This p-value so for the p-value that we calculated, it was less than 0.01, and this p-value is statistically significant, which means that there's enough evidence to reject the null hypothesis, which basically we can conclude that there is a difference in the level of bias in the 5 different generative AI tools. And the data figure that isn't showing up here basically shows the distribution of the bias score calculated for each AI program. Okay, so this is my discussion. So there are different levels. Wait, there's a difference in the level of gender bias expressed in the 5 different AI tools. So to test if the prompts we created are neutral, we also conducted an ANOVA test for the different prompts, and we got a p-value of 0.52. So this p-value is not statistically significant, which basically indicates that there is no statistical difference between the prompts, which is a good thing because we tried to create the prompts as neutral and similar as possible to kind of reduce variability in the results. But despite their efforts to maintain neutrality in our prompts, some prompts, such as creating images of political leaders, resulted in male-dominated images due to the historical and statistical prevalence of male leaders. So this is something that we haven't accounted for in our research, but we have addressed it in our discussion. And I think addressing bias in AI can be done by ensuring that representative data and fair algorithms can be kind of integrated into generative AI bias. And reducing bias will enhance the reliability and potential of AI in diverse applications because now AI is becoming a very popular thing and it's being used in multiple different fields like in healthcare and finance and things like that. And yeah. So these are my acknowledgements. I want to thank my mentor, Ms. Megan Joyce, and she kind of helped me come up with the idea for my experiment, assisting in making prompts, generating the equation for the bias score, and so much more. We met multiple times a week, every week, to brainstorm and discuss and work on my research paper. And some other people that I want to thank is Mr. Warren, who helped me fix mistakes in my draft manuscripts and proofread it. And also I want to thank David, who's another student here, who kind of proofread my introduction and helped me improve it. And yeah, thank you very much for listening to my presentations, and let me know if you have any questions.
Awesome. Great work. And I actually pulled up your data figures in case you wanted to chat about them. I did have a question about creating the prompts. And because this figure didn't show, I wanted to ask you to go through kind of the different categories of prompts and why you decided to have them, all a little bit different in sort of category blocks.
Yeah, so all my prompts kind of had a similar sentence structure, but they did kind of differ in what we asked. So we asked about different roles and career things. Like we said leader and parent, which are two kind of roles. And then we also used some adjectives like emotional, intelligent, and athletic. And then we also used some action words like cooking, building, and driving. And then we asked some experience-based prompts like wearing a baseball hat or if they have long hair. And this was kind of to ensure that different aspects of a person are kind of accounted for when we look at gender bias.
Awesome. And then other question is just, I know you had taken AP Stats before coming to Headwaters and starting this program, but I wanted to ask a little bit about your experience using the stats. And I know Maddie had just mentioned some of, the surprising things about all the numbers. And so we had to do this other calculation of coming up with a bias score before you could do the statistics. So I wanted to ask you a little bit about that experience.
Yeah, so coming up with the equation for the bias score was a little difficult because I haven't seen any other research papers take this type of approach to calculating bias. So it took a lot of brainstorming and stuff, but after the equation was set, it was kind of easy to go through and calculate the score for every single prompt, but obviously it was a lot of numbers involved. So it definitely helped to use Google Sheets to kind of keep everything organized. So yeah.
Yeah. So, we had to go from that qualitative, like, is it a male or is it a female, that image that's generated, into something quantitative that we could use numbers to actually statistically analyze, right? Okay. And then for you, you were thinking that there wasn't going to be a difference, right, between all
Yeah.
5 of the tools. But as we can see here, some of them are more biased than the others.
Yeah. So my thinking was, since almost all AI tools kind of use a similar data set, that kind of bias would be transformed into the AI program. But obviously from the results, you can see that that's not true. And I think this is because like the algorithms for different tools differ, and some tools maybe have algorithms that kind of take into account for collecting diverse data to ensure that the bias isn't really interpreted in the program. Yeah.
Great. All right. Well, wonderful job. And thank you so much for this, having me help you with this super interesting project. It's, not something that I really had experience in. And so I was learning all about generative AI tools right along with you, which was super fun.
Yeah. Thank you.
All right. And next up, I'm going to bring Karina back up, and we have Tara, who's next. So Karina, if you could introduce Tara, that would be wonderful.
Yeah. Hi again. So I also had the opportunity to work with Tara, who was interested in understanding how the loss of biodiversity might affect humans. And so working together, I noticed that she'd become like extremely knowledgeable on big topics in disease ecology. So I'm really excited for her to share more of that with you now.
Okay. Hi everyone, my name is Tara, and today I'll be presenting my research about the effect of biodiversity on zoonotic disease risk, which I worked on with my mentor, Karina. So first, what is biodiversity? Biodiversity is the variety of living things, and it's a very important component for many ecosystem processes. Species richness is often used to represent biodiversity by calculating the number of different species within an area. And zoonotic diseases are diseases that spread from animals to people, and biodiversity has a direct effect on the risk of transmitting zoonotic diseases. So there are two common hypotheses about how biodiversity affects disease risk. This is the dilution effect and the amplification effect. So the dilution effect states that with more organisms present, there are more possible hosts that aren't capable of spreading the pathogens. And as reservoir hosts transmit the disease, the pathogens get diluted among the dead end hosts that are unable to continue its transmission. And so because of this, there's a lower chance of the disease reaching to humans. But on the other hand, the amplification effect states that if more organisms are available, then there are more possible carriers for that disease. So then the disease would actually spread faster. So the two diseases that I studied in my research question were Salmonella and Lyme disease. So salmonellosis is a prevalent zoonotic disease in the United States and is caused by a rod-shaped bacteria called Salmonella. Salmonella harms the intestinal tract of organisms, and it can be spread through contaminated food or water. And some organisms that frequently carry Salmonella include chickens, ducks, turtles, and lizards. And the bacteria from these animals can spread to humans through direct or indirect contact. And Lyme disease is another prevalent zoonotic disease in the US. It's usually transmitted through a bite of a black-legged tick, and the bacteria called Borrelia, which spreads from the tick bites, are what causes the Lyme disease. So reservoir hosts for this disease carry the Borrelia bacteria, and white-footed mice are reservoir hosts for this disease. So they carry Borrelia and they infect the ticks that feed on them. And then once these ticks have been infected, they then bite humans, which is how humans get Lyme disease. Okay, so my specific research question was, what is the effect of species richness on the human disease risk of getting Salmonella or Lyme disease? And I hypothesized that if species richness decreases, then the disease risk for both Salmonella and Lyme disease will increase. And this is because in an area with higher biodiversity, it is less likely that a single species, like a reservoir species, would be able to dominate. There would be many more species present that aren't capable of transmitting the pathogen, therefore diluting it before it can reach other organisms like humans. And with fewer species present, there's also a higher chance of that pathogen reaching humans. So to conduct this research, my mentor and I first began by collecting data, and we found 2018 species richness data from the IUCN Red List, and this included a heat map of the species richness across the US. And if you look at my slide on the left side, you can see that heat map. And then we also had 2018 Salmonella and Lyme disease data from the CDC, and the data set for each disease showed the incidence rate for cases per 100,000 for every US state. Okay, so then we created a computer program using the programming language R, and we imported a map of the US with state boundaries and overlaid it with the species richness heat map. We aligned the coordinate reference systems between the US map and the border map, and then this allowed us to be able to see the species richness per US state. And then we calculated the average species richness per state so that we would be able to see a single species richness value for each US state. Okay, and then we decided to exclude Alaska and Hawaii from our study because of their unique geographical factors. Alaska's harsh cold climate conditions and Hawaii's isolation and high tourism rates often introduce extra variables that affect disease transmission, and these factors aren't present in other US states, so we decided to just exclude them. So after we had this data ready, we merged the species richness data with the Salmonella and Lyme disease data on Data Classroom. And to identify the relationships in the data, we applied a linear regression model to analyze the relationship between Salmonella incidence rates and species richness, as well as between Lyme disease incidence rates and species richness. And then lastly, we used a linear correlation equation test to assess the significance of these relationships. So from our results, we found out that for Lyme disease, there was a negative relationship. It had a p-value of 0.05, showing that this relationship was significant. So as Lyme disease as species richness increased, there were fewer Lyme disease cases, but the R value for this was only 8%, which means that only 8% of Lyme disease cases can be explained by species richness. So there are a lot of other factors that can affect disease transmission. And then for Salmonella, there was a positive relationship, which showed that with more species richness, there was also more Salmonella cases, and it had a p-value of less than 0.01, also showing that this was a significant relationship. But just like Lyme disease, it had a low R value, meaning that there are a lot of other factors that affect disease transmission other than species richness. Okay, so we had initially hypothesized that the dilution effect would apply to both diseases. However, the results showed that the amplification effect occurred for Salmonella, so increased biodiversity led to more cases of Salmonella. And what I didn't consider when forming my hypothesis was that Salmonella can spread to humans both directly and indirectly. So there was a wide variety of sources of Salmonella, and a majority of animal species are capable of carrying Salmonella. So increased biodiversity meant that the added species had a really high chance of being host for Salmonella, which led to more exposure and higher Salmonella risk for humans. But on the other hand, Lyme disease could only be spread by the bite of a black-legged tick, and the tick can only get this pathogen through small rodents. So in this case, increased biodiversity meant that there were a lower proportion of rodents to the rest of the organisms. So this reduced the number of ticks that can acquire the Lyme disease pathogen, and thereby explaining why Lyme disease prevalence lowered with more biodiversity. One source of error that could have occurred during data collection was that the species richness was averaged per US state, which isn't as accurate as looking at species richness of a smaller area like a county. But despite testing with a broader area of land, a significant relationship was still observed between Salmonella, Lyme disease, and species richness. So this research suggests that conserving biodiversity can help reduce vector-borne diseases like Lyme disease, but it may amplify the risk of zoonotic diseases with multiple hosts like Salmonella. And the negative relationship between biodiversity and Lyme disease shows that conserving biodiversity would be a big step in reducing some vector-borne diseases, but for Salmonella, where the amplification effect occurred, public health interventions will be required that monitor and control these kinds of infections across multiple species. So as I previously mentioned in my results, the R values for both of the relationships were pretty low, meaning that there are a wide variety of factors that can affect disease transmission, not just species richness. So some other factors are deforestation and climate change. And then also because these deforestation and climate change, they alter habitats, which increases the interactions between wildlife and domestic animals and humans. Okay, so some further studies that could be conducted are studying if human activities like urbanization and agriculture influence biodiversity and disease dynamics, studying how models can be made to better predict disease outbreaks in biodiverse regions, and studying how specific host species influence the transmission of zoonotic diseases. Okay, so before I conclude this presentation, I would like to thank Corinna and Megan for helping me throughout my research and for helping me prepare my presentation. Thank you guys for listening.
Great work. Awesome. Corinna, do you have any questions?
Yeah. Nice job on your presentation. I thought it looked great and it was very thorough. So nice job. So I was wondering now, with all of this knowledge from what you've learned from your study and how the host and the way that a disease is transmitted plays a role in all of this. Like when you see in like the news things about bird flu or like COVID, technically it could be zoonotic disease, are you thinking about how biodiversity might affect those diseases?
Mm-hmm. Yeah, I definitely am. Studying with this research showed me that like disease dynamics is very complicated, and so like seeing news about different diseases, it shows me how there are so many different factors and how biodiversity can also just be like a really small part of this.
Nice. I also had a follow-up question on your methods. So we had worked, we had to use a coding language to help format some of the species richness data. And it was just like part of being able to get it formatted for your analysis. How did you feel about that part of the research process?
It was definitely something new that I learned, and it showed me how to like connect different data sets to be able to view how they can be correlated with one another. And yeah, I really enjoyed it because it was a new skill to learn in this research process where I did learn so many new things.
Yeah, I agree. It's definitely a nice tool to have, although it's intimidating at first.
Yeah.
Well, you came up with awesome data, and to add that coding in is just even better. I had 2 questions for you. One was, did you think about timescales at all when you were trying to collect your data? Did you ever think about trying to get data from different years and see if there are any fluctuations in species or the disease variable?
I didn't really consider getting it from different years because I thought that like the species richness wouldn't have changed that much within like the past years, but definitely I could have gotten data from many years ago to see how that affected it. But for this research, I only got data from 2018 because that was the year where I was able to find Salmonella, Lyme disease, and species richness data all in 1 year. So I wanted to keep it consistent that way, which is why for now I only had 2018 data.
Yeah, that makes a ton of sense. I know, at least for Lyme, it's been like moving around the country and wasn't in some states even a few, years or decades ago. So that could be really interesting future research. And then my other question was, you at the beginning, I think, were just thinking about doing one disease, and you ended up with 2, and they ended up having 2 opposite and very different results. So, what was that thought process like for you of finding diseases to use and choosing those 2?
Yeah, I initially had just was gonna study how salmonella is affected by biodiversity, and I wanted to do salmonella because I needed a disease that was pretty common within the US so that I would have a lot of data. But then, so I conducted my linear regression on salmonella, and I found out that the amplification effect had occurred, which was not supporting my hypothesis. And previously, I had read research papers about Lyme disease and how the dilution effect occurred with that. So then I wondered maybe it was because of the disease itself that changed whether the dilution or amplification effect occurred. So then I decided to add Lyme disease as well. And then it turned out, yeah, it was because of the diseases and how their transmission processes are different that can change the results.
Awesome. Yeah, well, it's really interesting that you had both and that they had such different results and that you have all of that research to back that up. So that is very awesome. All right. Well, thank you so much and great job. And next, I would like to bring up Danny, who is going to introduce our last presenter for this session, Zachary.
Hello, I'm Danny Nilsson, and I have the pleasure of introducing Zachary here. It's been fun working with him this summer on his project. He was really interested in the effect of government subsidies and incentives on buying power, essentially consuming electric vehicles. So the relationship between government incentives and purchases of EVs. So he's done a lot of work kind of poring over online databases and looking at sales data and government incentives. And he also made his own survey that he had people participate in to gather some sort of consumer buying behavioral data. So yeah, he's been great to work with. Real pleasure each week, and real fun person. So, all right, I'll leave it up to him. Thanks.
Awesome. All right, Zach, up to you.
So I investigated the effect of government incentives and what they did to electric vehicle sales. So climate change, as we all know, causes rising temperatures and sea levels, which impacts our health, ecosystems, and the economy. Transportation emissions are a major contributor to climate change, and electric vehicles have a smaller carbon footprint than gasoline vehicles, so they're potentially a solution to this. And consumer adoption of EVs is slower than expected due to factors like government incentives in the past years, where they weren't really, they didn't like, since weren't as many before, it was slower for people to adopt. So government incentives such as like rebates, they aim to make EVs more accessible to everyone. And my hypothesis was that government incentives do increase EV sales. So I found studies that show how monetary incentives significantly boost EV sales, but they don't address the range anxiety that some people had. Um, my research identified that there's key reasons for EV purchases, and it highlighted how important financial incentives are, and how like the effectiveness of policies promoting EV adoption and how they can reduce greenhouse gas emissions and combat climate change. My methods. So I conducted an analysis of how government incentives impact EV sales by examining public domains and publicly available data. So this involved like evaluating various like incentives and like their effectiveness in promoting EV adoption. A major like website I found, like our database, was the 2024 EV sales records for the U.S. Department of Treasury. So they provided like insight into market trends and the role of financial incentives in consumer purchasing and their decisions. Then I gathered like data on the types of monetary values and government incentives, like tax credits, rebates, grants, subsidies, and I try to understand how these financial benefits influence EV sales. Then found more information from official government websites, policies, and industrial articles, so I could like ensure that the accuracy and relevance of the data I found was correct. Um, then I applied like statistical methods like Pearson's correlation coefficient and linear regression models to analyze the relationship between incentives and sales. Then I calculated the p-value using an online calculator to confirm the like significance of the findings, and to also validate like the conclusion that incentives are a key factor in boosting EV sales. And then finally, I also conducted an online survey, which gathered consumer opinions on EVs, what they liked and what they didn't like about it. I got the survey to show me like their concerns, which is like one of them, which was range anxiety. But they also told me how like impactful government incentives were in their decision of buying EVs. For my results, I investigated key factors affecting EV sales, focusing on like government incentives. So I discovered that incentives significantly boost EV sales. So in the top right graph, you can see, so over the years, it's a bit hard to see, but incentives increase in their amount. And then in the bottom right, you can see how EV sales have also followed this trend. And with this, I hypothesized that higher incentives would correlate with increased EV sales. And additionally, my survey results indicated that better rebates make people more likely to purchase EVs. Then analyze the sales data alongside incentives timelines, and I found like a strong positive correlation. I got Pearson's R value of 0.86, which is strongly positive, and a P value less than 0.001. So between the incentives and sales, which confirms that like higher incentives do directly lead to increased EV sales. And this my data figures. So that's the equation I came up with, my linear equation. The R value indicated that it's a very strong positive correlation. It means they're like one causes the other. And then the p-value was extremely low. And then you can see the linear regression model. And yeah, this is my discussion. So this investigation like sheds light on what drives EV purchases and the effectiveness of government incentives, and shows how EVs offer a crucial way to reduce environmental damage and combat climate change and mitigate the effects of it. Highlights the need that we need to understand the sales dynamics of EVs. The research confirms that there's a positive link between government incentives and increased EV sales, supporting my hypothesis earlier that incentives do lead to higher sales. Also, my survey results reveal that while incentives are a key factor, other considerations also affect consumer decisions like range anxiety and um, how far it can travel. But I also got information about environmental benefits and how they like those. But despite the strong evidence, there were also limitations because there were potential biases in my survey, because California is the state with the highest EV adoption rate. So it was more likely that I found people who did like EVs. So that was one limitation. But my findings really do show that, like, how effective incentives are in increasing EV adoption. But overall, this research highlights the importance like targeted policies and incentives have in promoting cleaner transportation and advancing climate change mitigation efforts. So I'd like to say thank you to my mentor, Daniel Nielsen, for his support, math help, organization, and advice. And also a big thanks to Karina for helpfully reading and commenting on my paper. Here are my references. And thank you. That's the end.
Awesome job. So much information in there. Danny, do you have any questions to start?
Sure. Sort of maybe like less of a question, more of a human nature thing, because this is relevant. This week in Reno, we just ended a week-long celebration of classic cars. It's Hot August Nights, if you're familiar with Reno during this week of August, first week of August every year. So Hot August Nights is like people drive their hot rods from all over the country, and these are all like classic cars, gas guzzling, hot rods. And so it seems like, well, and the other part of that is that as you might imagine, the average age for people that attend this is like pretty high. So my question is, do you think that, like, no matter how much we incentivize electric vehicles and no matter how good the technology becomes in terms of reliability, do you think there's like just a natural human instinct that there's always going to be some core group of motorists that just don't want an EV? They just want to burn gas.
That's interesting. I think like younger like adults, well, they like kind of grew up with technology, so they might be more open to like accepting EVs. But I can see like older adults might be like more cautious towards this because they grew up with like familiarity on like gasoline cars, and like they might be like less motivated by like environmental concerns.
Yeah. Cool. Thanks, Zach. Yeah, great job. Great presentation. Good work.
Awesome. I had a question. You mentioned that one of the big concerns, one of the big incentives would be a monetary incentive for people to switch. And one of the concerns that you found in your surveys was range anxiety, right? And so I was wondering if you also asked or thought about asking people how far their average car trips actually are, to see if that would actually be a concern.
Yeah, that's a good question. Yeah, I should have asked that, but yeah, well, alongside with asking that, I guess I could search up like the average of like how far EVs can travel and see if like there need to be more like charging infrastructures around like the world to increase EV sales.
Yeah, I think the availability of charging stations definitely seems like it's something that people would gravitate towards as a reason to switch. But I think that I've seen average miles per trip that, you know, people generally drive is very low. And a lot of EVs have a couple 100 miles of range, which is not anywhere close to your, you know, trip to the grocery store.
Yeah.
Was there anything else that you were thinking about including or didn't include, or were there any results from your survey or comments you got from people that surprised you?
Oh yeah, I got one comment that like I guess like some people like aesthetically like EVs more, which is one factor I didn't consider before. I mainly just thought about the environmental factor, but one thing I wish I got like maybe more responses. Yeah.
Awesome. Danny, did you have any other questions?
No, that was good.
All right.
Thanks.
Yeah. Well, thanks, Zach. That was awesome and great work. And that is it for our first session. We do have another session of presentations coming up in a little over an hour, and you can find that link on the Headwaters website as well. And I just wanted to put a plug that we do have spots available for our fall research experience. And so if this is something that interests you, coming up with a project, you know, experimenting or asking a question about something that you're interested in, something you want to know about the world, we do have spots available in the fall research experience that will start at the middle of September. And so you can join us on the Headwaters website if you are interested. But thank you all so much for joining us. These students put in so much work this summer and they did such a great job and found some interesting things that they weren't expecting. They had to address challenges when they ran into problems finding data or field sites, and they rose to the occasion and did such a fabulous job. So thank you all so much for joining us, and congratulations again to all of the students. You did an awesome job, and I am so looking forward to reading your final manuscripts in a couple of weeks. Thanks, everybody.